Let's solve a couple of problems when calculating wave velocity are given to us. Here is the first example. A truck accelerates from 20 meters per second to 20 meters per second. Find the work done on the truck. Given its mass is 2,000 kilograms. Okay, let's go ahead and draw a situation for this. We are given that the truck accelerates from 20 to 30. So let's say here is our truck before accelerating. So before it accelerates, it is going at 20 meters per second. Let's write the down. And then after accelerating, it goes a little faster. So now it is at 30 meters per second. We are asked to find the work done on the truck. How much is the work done on the truck? Give its mass is 2,000 kilograms. So we know that mass of the truck that give, let's just write that down over here, 2,000 kilograms. We need to calculate the work done. So how do we calculate work? Well, we have seen now for quiet work done is calculated at the force acting on body multiplied by the displacement of the body. Okay, now do I know what the force is now? No, that's not given in this place. Do I know what the displacement it is? That also not given. We are only given the initial and the final velocity and the mass. What do? We can use this data and calculate what force and displacement is, and substitute and calculate, right? But guess what? We have already do this. If we plug and somewhat, we will eventually arrive at the equation called the work energy theorem, which says that work done equal change in kinetic energy. So work done equal final in kinetic energy minus the initial kinetic energy. And this equation can be derived from here. And then equation is basically saying that the work done on a body basically tells how much kinetic energy is added to the body. So this in the example, if we find out that 10,000 joules of kinetic energy was added to the body, this means that the work done was 10,000 joules. So I just have to calculate how much kinetic energy was added when the car accelerated, and that self represent the work done. And if you need more clarity, we have talked of a lot about this in previous video called work energy theory. It would be great idea and watch that video and then come back. Anyways, now by calculating is and how much the initial kinetic energy is, we can now calculate that the work done is. So get ready to put and see if you can try this yourself. And to recall, kinetic energy is half mv squared. All right, let's do. So what is the final kinetic energy of our car? That's going to be half m into the final velocity squared. And we can tell that final. So we can now plug in these values. And if we simplify it, we get 2 goes in the time, so we get thousands here, and 30 squared 900, so we get 1,000 kilograms. This times 90 meters squared per second square, and that gives us this 5 zeros, right? Kilograms meter square per second square. Now this is the SI units of energy, isn't? We also call this as joules, so we just call it as 900,000 similarly that initial kinetic energy. Well, we have into the initial velocity squared. The initial velocity we call that as UA, call this is U. And again, if we substitute and simplify, let's go down a little. Okay, so if we simplify, we get again goes 1 times as 1000 kilogram into 20 squared is 400. This time I will get 400,000 joules. So this is the initial kinetic energy. This is the final kinetic energy. Now work done just represent final minus initial, meaning how much kinetic energy go added. So we can so work done on this track should equal final, which is minus joules. How much is that equal? That is 500,000 joules. This is our answer. So let's put everything in one. So this equation is basically saying that the car gain, the truck gain 5,000 joules of kinetic energy. And so that must be work done on this truck. And we can currently use work energy theorem to calculate the work. All right, let's try one more. A pretty similar problem, so idea to pause and see if you can try yourself first. All right, that's 500 kilogram terms traveling at 30 meters per second, brakes and comes to stop. Calculate the work done on the team. So we have which is initially traveling. So initial traveling at 30 meters per second. So that it is initial velocity. The units breaks and comes to stop. So that means that time decrease. So after it comes to stop, that means the final velocity is 0. We need to calculate the work done on the, and again we are given the mass of tempo. The mass given is 500 kilograms. So we can do the same things what did before. We can say work done is how much kinetic energy get added to the tempo. So from work energy theorem, we say work done equal the final kinetic energy minus the initial kinetic energy. This times what the final kinetic energy. Well, the tempo is at rest, velocity is 0. So kinetic energy becomes 0. Okay, what is the initial kinetic energy? Again, we can say it's the half times mass times the initial velocity squared. And again, if we substitute and if we simplify, we will get this is to be joules. You can check that, you can use it and check the calculation. And so work done becomes final kinetic energy, which is 0 minus the initial kinetic energy, which is 225,000 joules, and we get, and that gives us minus 225,000 joules. That minus sign is important. Okay, so this time the work done on the tempo is a negative number. Negative number saying we remember work done represent how much kinetic energy gets added, but this time the kinetic energy was removed. Since this kinetic energy is removed, we are basically negative. The negative sign is saying that the kinetic energy, anyway, this kinetic energy is removed. So by definition, this is the work done on the tempo. So when velocity are given, work done can be calculated directly by using the work energy theory.